how does this repetition affect the genome over time, or the genome evolving and changing? So when you have the insertion of the transposon, that is going to interrupt and alter the gene function. Then you're going to have multiple copies of a certain gene, whether it's coding or not coding. Just having duplication, that's going to lead to genes with related functions. If you have the same tidbit or fragment of DNA in one spot, well then down the road it's going to probably do the same thing, whatever that function may be. With the genes, they may diverge by all the accumulating mutations. So diverge would mean to branch off basically and be different. So too many mutations accumulating and building is going to cause drastic change. And in this case, we could see pseudogenes being made. So pseudogenes are bits of DNA that served a purpose, that had a function in our body, and then all of a sudden there are too many mutations, too many changes, and now it's non-functional. Now in this case, that would be something that once worked, now does not work for some function. Also, with the genome changing, we might have new genes which actually do have new functions as well. So it's not just like a cease and desist, but it could be creating new genes which are different, and that's basically what evolution is, a change in something over time. Another example of something that is kind of repetition but not identical is what's known as a multi-gene family. So this is where we're going to have similar genes that serve a similar purpose, but not exactly identical. So we see this multi-gene family in hemoglobin. So it's kind of hard to see by this slide. You might want to Google the structure of hemoglobin. So hemoglobin is a type of protein that has iron in it, and it carries oxygen throughout our bloodstream. So the shape of it is really important. In this molecule, in this protein, there are 4 parts. So there are 2 alphas of the globin molecule and 2 betas. Now, an alpha protein is like a spiral protein. A beta is like a sheet. So if you had like a ribbon and you laid it left and right on top of itself, and then again the alpha would be like wound up. So again, you might want to Google that. So in this case, you've got, if you look at the picture, you have alpha and beta on the left and then alpha and beta on the right. They're not identical, even though they're pretty much the same thing. The one's on the left, one's on the right. They're mirror images, so very similar, but not identical. So when you look at the chromosome at the bottom, where it says chromosome 16, you can see alpha 1 and alpha 2 on that chromosome. They're near each other. They are very similar because they're basically going to be producing the same protein after transcription and translation, but not identical because they're on the left versus the right. And it's going to be the same thing for the beta globin. It's going to be very similar, but not identical. So this would be an example of a multi-gene family where, again, you have multiple genes. They're pretty much doing the same thing, but not identical. Almost identical, but not quite. You want to come talk? Come here. Go ahead. Got this?
Hello. My name is Rose. And
you like blood cells and hemoglobin?
I'm a boss of the Superman.
Okay, goodbye.